Welcome to the demonstration of the Tableau dashboard showing the spatial temporal variations of NO2 and PM2.5 levels and their respective associations with taxi and car park availabilities. We'll be introducing the features of the dashboard sequentially, starting from the first portion on the top left corner right here. So this displays the correlation between the change in PM2.5 levels and car park availability based on three types of correlations. So that includes Pearson, Spearman's rank, and Kendall rank correlation. So this is shown across the 5 regions in Singapore. So as a user, you will be able to select a single type of correlation from this drop-down box over here. And you can also select multiple regions or just a single region from this drop-down box on top. So once the custom filtering and selection is completed, by hovering your cursor on the selected regions, will display information including the type of correlation, region, and also the corresponding correlation coefficients. So from this map, we can see that the correlation between the change in PM2.5 levels and the car park availability are relatively weak across all the regions. And in fact, statistically significant correlation is only observed for the central region for all 3 types of correlations. The second portion is the right half of the dashboard, and it displays a map of correlation between change in NO2 level and taxi availability for the 421 terrestrial data points across Singapore. As a user, you will be able to select a single type of correlation from the drop-down box over here. And you will also be able to select a single or multiple points from the map, either by holding onto the Control or Command key on your keyboard while selecting the points, or you can also utilize the following tools in Tableau to do the selection. And I would like to make a note that without selecting any specific correlation type, the correlation value reflected on the points actually shows the sum of all the correlation values, which does not have any statistical implication in our study. Once the filtering and selections are done, the histogram will display the distribution of correlation coefficient of the selected correlation type based on the selected points. And the scatter plot will display the change in NO2 level against the change in taxi availability on a weekly basis between 15 January to 25th November 2020. By hovering your cursor over the various elements on this portion of the dashboard, it will display information including the type of correlation, coordinates of the point of interest, and also the corresponding correlation coefficients. And specifically for the scatter plot on the bottom right, the week ID and the respective levels of NO2 and also taxi availability will be displayed. So from this map, overall, all 3 correlation methods resulted in similar spatial patterns for the correlation between change in NO2 level and the change in taxi availability. The general trend shows that positive correlations are mainly observed in the northern portion of Singapore, and the negative correlations are observed in the western half. The last portion of the dashboard is on the bottom left, and this displays a map of hotspots and cold spots distribution for the correlation between the change in NO2 levels and taxi availability for the same 421 terrestrial data points across Singapore, as we have seen from the previous portion of the dashboard on the right. As a user, you will be able to select a single type of correlation from the drop-down box. Once the selections are done, by hovering your cursor over the points of interest, it will display information including the type of correlation, the clustering category, and also the coordinates. From this map, there is a notable north-south divide in the statistically significant hot and cold spots. Specifically, the cold spots are observed in the south and east coast, and the hot spots are observed in the north. That will be all for this sharing, and I hope that this dashboard will be helpful for your data exploration regarding the relationship between air quality and mobility. Thank you.